Hello.
Hello.
Hi, Saiti.
Hi, Aditi. So, shall we begin the session?
Yeah, sure. Let's start.
Yeah. Good evening, everyone. Girls Club Vishakhapatnam chapter welcomes you all to the webinar on ethical hacking. I'm Sahiti. I'm your host for today's webinar. Now, I would like to take a few minutes to give a brief description about our today's speaker, Ms. Aditi Badnakar. Aditi is currently working as a software engineer at Microsoft and is the founder of Digitized and Infinity Hacks. Hacker, engineer, security researcher, blogger, techno-sociologist, and public speaker are the titles associated with her. She has been recently awarded as the Hackernoon Contributor of the Year, Technology 2020. She is also speaker at ISEA International Conference on Security and Privacy 2020. So before handing over the session to Aditi, I would like to give the overview of today's session. The first part of the session involves the basics, followed by a quiz, and the next part of the session involves stuff related to networking packets, some attacks, and how to defend them, followed by a Q&A session. An important reminder to all the attendees. A feedback form will be shared at the end of the session. You'll be marked as an attendee once you fill the form, and the certificates will be sent to everyone who fills the form. That's it. So, Aditi, you can take over the session.
Yeah, sure. Thank you, Sahiti, for that introduction, and I'm really happy to be here talking to all of you. I know it is virtual meet, but let's make the best of it. So I'll walk you through it. We just have 1 hour, and the things that we are covering are pretty interesting and are usually covered for hours and days at length. So let's try to make the best of it. I'll start by introducing myself. Sahiti has done already the job, but just to repeat, like I'm working as a security software engineer in Microsoft, and I'm the founder of Infinite Hacks, and I've presented at different conferences before, which we can cover a bit in this. So basically, I care about security, digital rights, privacy, design ethics, and alternative education system, and obviously the inclusiveness of girls in tech, which is one of the major reasons why I'm so interested in doing this session. So Infinite Hacks is a place where we provide free resources and trainings for all the cybersecurity things. It ranges. It's a broad domain, so we try to cover as much as we can. A major part of it is spreading awareness in cybersecurity and digital rights and techno-sociology. So if you are not familiar with what techno-sociology is, you might be familiar with the documentary Netflix documentary Social Dilemma, which is kind of a very hyped version of what we talk about. And if you're really serious in accelerating your knowledge, like if you're super interested in cybersecurity, I would definitely recommend that you go and check out this thing, because most of the things are free and we will be starting at a beginner's level. So you can go check it out and join the community on Discord if you're interested to learn more, and we can have a direct discussion of whatever doubts you have on that platform. So in order to learn more about that, you can go to this link. This is my personal website, aditi.fyi, and it will give you 3 steps which you can follow in order to get the best of what we have to offer here. So enough of that. Now let's begin with what we want to do.
Aditi, are you able to share your screen? Have you shared your screen?
Yeah, I am. 1 second. I think it is shared. So it's streaming on 2 platforms, right? I think it's shared on YouTube and it's not coming up on Hangouts. So I think it is visible now on Hangouts. Let me know if it is.
Yes, it's visible.
Okay, awesome. Yeah, so we didn't miss much. I was just talking about me here and Infinite Hacks. So that's the website that I was just mentioning, aditi.fyi. Okay, so what's next? What is ethical hacking? So I took some time to go through all the questions that most of you submitted through Google Forms, and a lot of questions were there around: Am I like? Is there any prerequisite knowledge required? Or what is hacking? Or I am not familiar with computer science. Like I'm from a different domain, so is a thing for me or not? Now the basic thing is that if you have used technology, which all of us are using because you are here on Hangout or YouTube, you must be concerned about this field. It's like as simple as that. Because believe it or not, once you start understanding the protocols that we're talking about, you would understand how vulnerable each and every one of us is and how important it is to be aware in this particular domain, right? And there are a lot of misconceptions. I'll just take a minute or two to clear those things out. First is that hacking is not hacking social media or Facebook, right? Just get that crap out of head, because a lot of times, like especially in youth, it's like, okay, I'll learn hacking and I'll hack, someone's FB or Insta. Now it's not that. It's a very, not a good way to think about hacking. It's not about causing harm or doing something which is cool, but you're just doing it for the sake of fun of it. No, that's not what hacking, what we will be covering here, is, right? It's more of an art. It's more of a field which needs a lot of focus. It needs a lot of curiosity in you in order to be a great hacker, and it needs a lot of efforts to go to the level deep enough to create your own hacks. So that is one thing. Second is that hacking is not a crime. A lot of times that happens that people are like hackers. They have a judgment associated with the term hacking, that hackers are someone who are like cool or crazy, or they just steal data. No, that's not like that. So if you want to understand it clear, it's like a locksmith, right? Now a locksmith knows how to open a lock, but then the person is there to help you. He or she is not the one who goes around taking logs across houses and doing stealing. So they have the power to, but they choose to do it in a defensive manner and not as an attacking manner. Similar goes with if you know how to shoot using a gun, right? You can either attack people or you can defend people. So you can be a terrorist or you can be war heroes. So it's a power, it's a skill. If you learn it, now it's up to you how do you want to use it. And we would want you to use it ethically. That is why the title is named as ethical hacking, that you learn the skills and do it for good. Because believe it or not, there are a lot of great opportunities when you try to do things ethically. You can be security researchers, you can be cybersecurity engineers, or you can have bug bounties. You can report bugs in the technology products and earn a lot of money there. So there's a lot of scope in doing and understanding cybersecurity and doing ethical hacking. So that is about ethical hacking and some of the misconceptions you might have had around that. Now let's begin with today's session, which is essentially on sniffing. So Saiti already covered what all we'll be discussing. So let's talk about sniffing and networks in general. Like, why are we even talking about networks? So the major thing is that network is one of the most core aspect of hacking or cybersecurity, right? Whenever you will be diving deep into this field, you'll know that understanding networks is one of the things which will give you edge in knowing more about different kind of hacks which are happening. All right, so networks are at the core of hacking, and in this particular session, we'll be trying to understand more of how computer networks work and what kind of vulnerabilities are there and what kind of attacks can possibly happen in computer networks. So how is what I'm speaking reaching to you? That's like a basic concept of knowing networks. Even if you're not familiar with like OSI layers or packets, segments, or a lot of things, if they feel alienated to you, you just remove all the crap, everything that you have studied in books which doesn't make sense. Just think about a very basic thing, that I am here speaking to you, and this information, my image, and this all the slides that I'm sharing, they are reaching to you at your end and displaying in your browser or whichever app you are on, right? So how is this communication happening? It is going through several different layers, right? It is starting from my browser, from where I'm joining this meeting, and then I'm sharing my desktop, so that is another set of data, and all of that information is getting translated into packets and traveling through wires and wireless and then reaching to you, right? So there are like a lot of layers which are involved, and whenever there comes different set of layers, there comes different set of protocols. So if you open a web page, it is HTTP or HTTPS, right? That is one protocol which operates at application layer, the topmost layer. And when it goes down and down and down, it further gets enveloped into different protocols. So to make a diagrammatic sense of it, let's have a look at the OSI layers, right? Just a quick check. This thing is visible, right? Because I'm not actually.
Yes, Aditi,
Oh,
we
okay,
can
cool,
see.
cool, awesome. Yeah, so let's talk about the OSI layers. Um, if you have a look at it, there are 7 layers in it. Okay, the topmost is the application layer where you all are connected. So it depends on what kind of content are you sharing. Are you sending an email? Then there's a different protocol to it. The protocol is called SMTP, which is associated with email. Similarly, if you are on an FTP thing or an IRC, these are different apps, different ways of communicating. IRC is like a chat channel. So that will operate on a different protocol. If you're just using a web page, it'll be operating on HTTP or HTTPS. So different kind of applications, they understand different kind of protocols. So you can draw the analogy of protocols to languages. It's just like some people understand a particular language, so they can just talk in that language, right? So protocol is like that. For just a second, I got some message on sharing the full preview. Just give me a second. I'm just checking if there's something going wrong on this stream. Okay. I think this should solve it. Yeah, so we are talking about different OSI layers. Application layer, then comes the presentation layer. So whenever we are talking, this stream is going on, right? So someone is doing the bookkeeping. Someone is doing the bookkeeping that these many packets have been transferred, and this is, the session and authentication of the people who have logged in. Someone is doing that, and that all is happening in the presentation and session layers. That how is the connection established? Is it a live stream? Is it like a streaming video, or is it just a chunk of data which is transferred once and there's no back and forth communication? So based on that, there are different protocols at 6th and 5th layer, which is presentation and session layer. Usually the top 3 layers just bridge into one, so there's not much differences when it comes to different apps, but the real fun starts from layer 4th onwards, right? Which is the blue one here, which is TCP, UDP, SSL, TLS, SCTP, and they're like different protocols operating at this particular layer. And then comes the network one, and towards the end it's the data link. So don't be confused if it's not making sense. We'll just see it live right now as to how it looks like actually on the wire, but just get a sense of it, that when you are logged into an application, it is capturing your information, and all of it is going through all these different layers, 7, 6, 5, 4, 3, 2, and finally it will be converted into binary, right? It will be converted into 1010, and that would be transferring through your wires in the form of voltage fluctuations, which is 010101. And all of that information, it got reduced to wires. It will go through the wires to the other person, and then again the reversing of this thing happens. So when you receive this information, the computer starts at physical layer, which will be at your, the Ethernet connection that you have. It will start from there through the wires, and then it will open the envelopes one by one. So it will be going to the data link, and then the network, then transport, session, presentation, and finally you'll be seeing it in your browser. So that is how it happens, right? It funnels down, and then the funnels open back again at your end. So these are the 7 layers, and the thing to note here is that each of them are having a lot of different protocols. And what does it mean from a hacking perspective? All of these protocols are vulnerable in some sense or the other. So that is why it's very important to understand what are the different layers which we are using here, right? So where does the sniffing happen? The sniffing that we'll be doing today will be happening on a data link layer, which is layer number 2, right? So that is where we'll be doing the sniffing. So let's try one thing. Let's try sniffing through WireShark. So I don't know how many of you are familiar with WireShark, but you are logged in your computer, so just open another tab and type WireShark. It is an app, and it helps you in sniffing. Okay, so what do you mean by sniffing? Sniffing is nothing but capturing packets. So we just talked about that all this information is going across wires in the form of packets. So sniffing, this particular tool will help you in capturing that, right? So to sniff means to get packets, to see what all is going across your network. So you can install WireShark. It should be pretty quick to do. Just make sure that you're not logged in some organization where it is not allowed to, because some corporates or some particular education institutions might ban it. So just have that clarity, and if you have it banned, do not use it. But if you are free to use it, if you're in your home network, you can install WireShark, and it will look somewhat like this. So this is what the tool looks like. Let me clear up the session once here. Okay. So this is what the tool looks like. Let me take it to the basic ones. Okay. We'll just right away start here. There's a session already running here. Let's open it from the beginning so that I can show you what you will see and we can navigate from there. Okay, so this is the first thing that you look at when you see WIRESHARK app. When you open WIRESHARK app, this is how it will look like. Okay, so you'll see that there is a capture thing. There are a lot of interfaces. One very interesting thing is that WIRESHARK can also help you capture Bluetooth packets. So we'll be able to see all the internet packets, no doubt in that, but we can also sniff on Bluetooth packets. So when your headsets are connected or when you're sharing a file through Bluetooth, you can see it, what is going on through WIRESHARK, right? So here you will see that there are different interfaces here. Now, if you would have used like ifconfig on Linux or Mac or ipconfig in your Windows system, you'll see that you see all these different interfaces, right? So these are essentially the interfaces from which your network is flowing to and fro the system. So WIRESHARK will let you choose which interface you want to listen on, right? Because if you connect a new thing, traffic might start flowing through that as well, right? So you'll see here, see, this is like a wavy thing happening here. So you can see that Wi-Fi Ethernet 0 is sending a traffic. So it'll make sense for me to capture this traffic packets. Others are not pretty active right now because there are no other connections. Just my Wi-Fi is connected. So we will try to capture packets on this interface. So once you have done your interface selection, you can start capturing packets. And it will collect everything, right? So you'll see a lot of data flowing in here. Now this data is especially the stream. I'm connected to Google Hangouts, so I'll be seeing all the packets going to Google Hangouts. Then all the other websites that I'm opening, all of them will appear here. Along with that, if there are any background apps, so if there some app is doing an update or something, all of these will be visible here basically, right? And if you open any one of them, suppose I'll pick this one. See, this is a TCP one. Let's just pick any TCP packet like this one. Here you'll see that this is, let's make basic sense of it. This is timestamp, so just chuck it, doesn't matter much. This is the source, this is the destination, right? So some remote domain, which is 173.194.14.6, some IP address is connecting to my IP, which is 192.168.1.2, right? And it is having a TCP connection. So we just talked about different protocols, and at layer 4, transport protocol lives, right? So we can exactly see how the transfer protocol, like transmission control protocol, looks like. So whatever information is here, right? Like if you are a bit confused, just type here, go to Google and type TCP header. Okay, yeah, how TCP packet looks like. You'll see that all these protocols at different levels, they have their own header, they have their own packet. So it's like a format. Okay, so how to send the information, just like in email you have to, from, and then your mail body of the email, right? Similarly here, like in TCP, it will tell you what should be in the header. So you're transferring information, it's a big deal for computers. So they want to know what is the source port, what is the destination port, right? And what is the sequence number, as in you're sending a lot of data, which sequence is this, right? Because they want to keep track that the data, whole of it, goes across the systems, right? So they need a lot of information to do that bookkeeping, that which packet is it and has it been acknowledged or not, the other system wants to get this packet or not. So all that stuff, it comes under this particular format. This is the header format, and you will find some or the other format for every protocol, be it TCP, be it ICMP, be it HTTP. Every protocol has a particular format, right? So we are talking about the TCP one. So this is how it looks like: source, destination port, sequence, acknowledgement number, blah blah. So now when you go to WIRESHARK, right, you'll see that all of the information is available here: source, destination, sequence number. It will tell you each and everything, right? And then the flags. So if you're familiar with the classic TCP handshake, if you're not, look it up later in the session. But if you're familiar with it, you can make sense that all these SYN, ACK flags would be here, right? So this is an acknowledgement bit. So they are like three-way handshake. So the last one is acknowledgement, right? So this is acknowledgement set. So this is a packet where the other server is telling me that yes, I acknowledge this connection and keep on sending more packets to me. So that is what is interesting. Like each of these packets is having some information or the other, and you can use it based on what is it that you're trying to look at. And similarly, you can go about in some other, this is a UDP protocol. You can see all the different headers here, the data here. Now this data doesn't make much sense, right? Like it's not very plain text. You cannot read anything here. And that is especially because of encoding or encryption, right? That is why you're not able to see the exact data which is going on. And you will also see 104 bytes on wire. So it's like finally when all this encapsulation is done, how many bytes are eventually transferred on wire, that will come up here. Okay, so the interesting things lies in these last three. The upper ones are just the envelopes on top of it. Okay, so that is how your WIRESHARK packet capturing looks like. Now let's go back to the presentation. Okay, so start capturing traffic on suited interface. We picked the interface. I picked up Ethernet 0, and my IP address I found it by doing ifconfig, and I'll see that my IP is 192.168.1.2 here. Okay, this is my IP, and this is the interface that we capture traffic on in WIRESHARK. So try to spot TCP packets and ARP packets, if any. So if you look at it here, after the source and the destination, there is this thing which is called protocol, right? So these are the different protocols which we were talking about. There is UDP, there would be TCP, ARP. Just start capturing the traffic on your system and you will see that there are a lot of protocols. RTMP, which must be doing something. Then there are certain proprietary protocols as well. And here it is, it's ARP protocol, which is address resolution protocol. Now, later in this session, we'll be doing an attack based on this particular protocol. And we'll learn about how this works and what is the attack all about. All right, but just for now, just note the format of it. It is sending something like who has this particular IP, and it is like whosoever has it, just tell it to 192.168.1.254. So this is my router address. So apparently my router is sending a broadcast to all the systems that who has this IP. Now why is it doing that? We don't know. We'll talk about it later. Okay. So this is what the different kind of protocols look like. So we saw TCP packets, we saw ARP packets. We can spot a TCP handshake. Try to do that. And then you would see a lot of packets and a lot of protocols, right? You can also try to put filters on it because WIRESHARK like throws a lot of things at you. So you would want to filter it out at some point or the other. So I can filter it out. Like if I want to say just filter things which are sending from my device, I can filter it out on the basis of IP address. So it is like you put address and then you put 192.168.1.2 and then you filter it out. So it will send only, it will filter out only the packets which have my IP as the source or the destination, all right? So this is here. Similarly, you can filter out the protocol as well, that I just want to see HTTPS packets or HTTP packets. So for now, there are no HTTP packets. If I see TCP packets, it will show me all the TCP packets going around. So that is how the protocol is working. And further, you can do more filtering on the basis of port. So suppose you are here, right? You can put a filter from here also. So this one is the source port 53524, and you can have that apply this as a filter, and you can select it, and then it will do all the filtering based on this source port. Okay, so that is another convenient way of applying filters. So I would recommend that you install this tool and try it out. Try to make sense of what is the kind of thing that you are looking at and what all can you spot from a particular packet. So each of these are like packets, okay? Different packets. Moving on next. So attacks lie at each of the OSI layers and different protocols that we just talked about. we'll be talking about the link layer, data link layer, which is layer 2 for this particular presentation, and we'll be trying to attack that layer. Okay. And yes, you just now sniffed. So sniffing is just that. You open Wireshark, and there are a lot of different tools as well. So what you just did was a sniffing on your own network. Okay, you tried to capture everything which was going across your network. And this is very interesting when it comes to attack. So suppose someone is trying to attack you, right? Someone is trying to do ARP poison at your own laptop. What is the quickest way to do that? To find it out. I mean, there are softwares and antivirus detection systems which are kind of expensive, but you can just open Wireshark and see the activity across your system, like what is the kind of data targeted to you and what is leaving out from your system. And if you make sense of it, you can find out, because there is a pattern in which attacker attacks. So if someone is doing ARP spoofing, you will see a lot of ARP packets in your Wireshark directed to you, right? So that is a way to figure out that, okay, someone is messing up with your network. And similarly, if you visited some website and it's doing some, because one can get hacked by just visiting a website, right? So if you visited some malicious website, you can see what data are you exchanging with that website, what are you sending, what is the website sending you back. So, and on the basis of that, you can try to figure out if there is something malicious going on in the background. So moving on to the next thing. Just 1 second, this thing got stuck. Is it hanging or something? I should just exit this. And Wireshark does take a lot of processes, so like processing power. So if it's trying to hang your system, then make sure that you exit if you're not using it. Okay, so let me see. Where are we next? God, it's stuck. Okay, so we did the TCP handshake, we spotted some data, and we talked that attack lies at a lot of different layers. Now the interesting thing is that, can you sniff passwords? So we just saw that we saw a lot of data and it was not making much sense to it because it was kind of encrypted or encoded, so we were not able to see to it as in what is going on. But still, can we sniff passwords? Like, is it at all a possibility that you can sniff passwords just by using Wireshark or some other sniffing tool? So the answer to that is yes. There is a lot of information which goes across your wires, right? You are not aware of it because you are always talking to the UI. You are just talking to the web browser, but in your packets, a lot of information lies, right? And there's a lot of sensitive information, including your passwords, your email traffic, your router traffic and configurations, your DNS traffic. A lot of those things go through your Wireshark, right? And if they are clear text, what do I mean by clear text? If they are not encrypted or encoded, we can see them through Wireshark. All right, so and it so happens that a lot of protocols, including Telnet, HTTP, SMTP, SNMP, these are like used at different applications. Like SMTP is for your email. Telnet was used long back. It's still used somewhat right now to interact with the remote computer systems. And then there is POP, which is again used in your emails. And there is FTP, NNTP, IEMAP. Just go around and read all of these. You must be familiar with HTTP, which is a very basic protocol. It's used for your web page, right? So HTTP is also vulnerable to your sniffing attacks, right? So what kind of sniffing can we do from an HTTP domain? So let's try to figure that out. Let's try to find a password by visiting an HTTP site, right? Now, I didn't create an HTTP website for this particular session. So what I'll do is that I'll find out a real HTTP website. And how do I do that? So how do you find on Google that find me some HTTP website which has login so that I can tell you how I'm sniffing it? So the process is called Google Docking, right? So Google Docs is a way in which if you write your query using that particular format, you will kind of get the URLs that you are looking for. So I am looking for a URL which has some admin login page and it has the protocol HTTP, right? So the Google Doc, which is kind of a syntax or a format in which you give your query, will be in URL admin login.php HTTP. So let's just type this in Google and see what we get, right? So I just want to find any website which is basically giving me a console where I can log in so that I can sniff the password, because I want to see what is going through Wireshark when I go to that website, and then what is the information I'm able to get. So let's do this query, and you will see that all these URLs, right, all of them are HTTP. And it's a way of finding out in Google search that when you provide this particular thing that it's in URL, it means that in the URL of the website, there should be admin, there should be login.php, there should be HTTP present. So when this happens, it finds out all the URLs which are indexed, and all of them are like HTTP websites. And you see like one of it, I think this is government. Let's not do this. Okay. Although we are not doing anything wrong here. We're just trying to sniff our own password. This looks okay. This is alltimecargo.com. Okay. And let me see what kind of traffic goes through my system when I visited this site. All right. So let me open Wireshark again, and let's hope our slides don't stuck this time. Okay. So I just opened Wireshark and I'll start capturing traffic. Okay. Here. So let me reset it, continue without saving, and let me revisit this website. Yeah. Now this is an HTTP website. So I want to find out the domain of this. I can do HTTP. Here it is. So this is the website and this is the IP address of that website. Okay. Which is 43.255.154.57. So till now I just did a GET request, like I visited this web page and I got a OK response and the website appeared in my browser. And I can also see the exact HTML of the web page because it is HTTP, it is not encrypted. So you can see the exact information which was transferred to your browser. So you can see the HTML, this is the same HTML which is showing up in your browser. Okay, and the protocol here is HTTP. Now if I go ahead and log in, say I did blank, okay, I just did this password and I did login. Now of course it is like a wrong password, but let's see what happened here. And you will see that when I did this post, okay, just look at it. What did we find? We find that there is my username, my password, and it's able to get it. It's able to get your username and password. And this is you doing it on your own system. Just imagine if someone else is able to sniff this information. That is why all of us say that use HTTPS, do not have websites on HTTP, because whatever information you will be sending on HTTP can be sniffed, right? Someone can directly look at it and find out your passwords. And this was a big problem, I think, a couple of years back when still HTTPS was not very prevalent and people were just sending, important information, their banking information over HTTP, and those were being stolen because it's as easy as this to steal information on sniffing, right? So we just saw that we are able to capture the username and password over HTTP, and it's just done simply by using sniffing on Wireshark, right? So that is what, that's the power of sniffing. So we just sniffed our HTTP packets, and so far you are just doing sniffing on your own traffic. Like this is your laptop and you are visiting that website and you are capturing your own password and understanding how it operates. But what about others? Like what about you want to find passwords of someone else who is on the same network? Is that possible? Yes, that's possible, and that is what we'll be covering in this session. But we have reached like half time, so I think there should be a quiz now. So we will talk about MITM, which is our second approach, which will help us to sniff on other other devices other than our own. And to go there, we need to understand networks a bit more. We need to understand how address resolution protocol works. So that is what we'll be covering after the quiz. For now, let's start the quiz. So Saiti, do you want to coordinate this, or should I just go ahead?
You can carry on, Aditi.
Cool. So I think we discussed that if you know the answer, just type it out in the Hangout chat, and then we'll see who all answered correctly, right? So there are 3 questions, and it's based on what all we covered till now. So the first question is, which OSI layer are we sniffing at? So we just sniffed using WireShark at some layer. Which one is that? Hello? So there are like 4 options, A, B, C, D. Okay. Cool, I'm seeing some answers. That's fine. I think just top 3 or 4 are selected. So chill. Let's wait for the second question now. The second question is, which of these protocols cannot be sniffed? So there's no clear text. Is it HTTPS? Is it FTP, SNMP, or Telnet? So like A, B, C, or D. And then the last question is, what is the way to find HTTP login pages in Google search? What is the way that we just now used? I know these are pretty basic, but these are just to, remind you of the facts, of the important things that we have covered till now, and something that will help you eventually when you will explore cybersecurity more. So that's A, B, C, or D is incognito mode, or do some advanced search, or use image, or use Google Docs. So I hope you answered that. And let's move on to the next section because we just have 15 minutes left. Okay. So why is sniffing a big deal? Because we just now saw that hackers can monitor all of your captured data packets and they can have fun with them, right? So that is why it's a big deal, and that is why we need to be aware of that. I think I'm still facing problem with the next slide, so just bear with me while I close this WireShark. We're up to something really interesting now, which is some real attack, which is still possible. So most times, like, I used to get disappointed because most of the hacks were like so old, and it was always like, I cannot do it. How do I try it out? But the attack that we are just about to talk now is something that you can try out yourself, and it is still very applicable because most of the protocols are still the same. They still work like the same way they used to work years back when they were created. So there are still loopholes, and you can still attack them. And why is this not working? Just give me a minute. Okay. Let's start at this particular slide. Okay, so we're talking about MITM, man in the middle attacks. Sorry about that. I think this should be fixed now. Before beginning to even understand MITM, let's make certain basic things very clear in our head. One is NIC card. What is NIC, NIC card? So you know that we are talking through IPs, right? I just showed you that my local IP was 192.168.1.2. Each of you on your own LAN networks are assigned an IP address, right? And along with the IP address, each one of you, like all the computer systems, they have their own MAC address, right? And that MAC address is something which is very unique. Like anyone can find you out if they have the MAC address and you are around. Right, so they can find you out, and that MAC address is basically embedded in your NIC card, which is your network interface card. And this is the card which is responsible for your internet today. If you do not have this card, you cannot access Wi-Fi, right? So all the machines come with the NIC card, and on that NIC card, you have your MAC address, which is a 48-bit address, and it is very unique. The last bits, 16 bits of it are very unique per individual, right? And then there's something called promiscuous mode that we'll talk about, and there is hub and switch. Now these four things you need to be very clear in your head before you start digging into sniffing and MITM attacks. So we just talk about NIC card. It is embedded on your chip. So if you want to open up some mobile and see it, you can go ahead and do it. We won't do that right now. Then there's promiscuous mode. So by default, your NIC card is configured in a way that you will only get the traffic which is directed to you. So if it is like, if the destination IP address is your IP, only then the NIC card captures your packet. Otherwise, the NIC card will just drop your packet. It won't do anything with your packet. So that is the default mode, but you can change the mode, right? You can set the promiscuous mode in a NIC card. There is a way to do that. And when you do that, you can hear all the packets in the network, which even those which are not directed to you, right? And that happens in a hub. So if you know about hub is a very old networking device, and it was like one of the initial ways of interconnecting computer systems. So what it used to do was that if the hub gets a message, if a hub gets a packet that I want to talk to a particular computer and I want to say hello to computer A, the hub will just send that packet to all of the computers connected to it. So it just doesn't know. It is like a dumb device which doesn't know that I should just send this particular packet to the person for whom it is intended. It didn't used to do that, right? So if you see this image, I'm sorry, in the hub, initially it was just shared, like all the network is just going across all the devices, right? So hub used to act like this. And that is why sniffing was way more fun back then, because the only thing that you need to do was make your NIC card into promiscuous mode, right? And you will start listening all the traffic, because hub is sending all the traffic to everyone, right? So you can easily sniff on that. But today we are not using hub. We are using something called switch. And switch is way more smart than what hub is. So in switch, you can, like, switch takes care that this particular traffic is just directed to this particular computer IP address and no other. So even if your NIC is in promiscuous mode, even if your NIC is looking out for all the packets which are sent to the machine just doesn't get all the packets, because switch is not sending all the packets to the machine. Switch is just sending the packet which is intended for that particular machine, right? So presently switch doesn't let, like, if there are like two computer systems, one is mine and one is my friend, in the same, we are connected to the same Wi-Fi router. If instead of the router it was a hub, I would easily sniff on my friend's computer, right? But right now it is a switch. So I cannot look at my friend's computer because the switch takes care of the packets. So it will not send any packet intended for my friend's computer to my computer, and I cannot sniff. So that is what the problem is here. Like, that is what the technical challenge when it comes to sniffing in today's world, right? So how do you sniff now? Like, the switch is taking care of it. I cannot get packets. So what do I do? So there are still certain ways in which we can bypass this limitation and sniff the traffic on someone else's device. So how do I do that? I would definitely need a NIC in promiscuous mode. That is like one important thing, whether it's a hub or a switch. But in switch, we need some more things, right? And this is the exact case where things like ARP poisoning or MAC flooding make sense. All right, so if you talk about switches, though they are, they are taking care of things, but still they operate on protocols, right? Like, they know that this particular traffic has to be handled in a particular way. So how do they make sense of it? Like, how do they know that, this packet is targeted just for Aditi and not her friend? Like, how would a switch know that? So they know that by basically creating a table. They have a table where there is a particular mapping of the IP address and the MAC address, right? So it will tell you that Aditi's MAC is this, because we just talked that MAC address is a unique thing, right? So my MAC is unique, and that is what the switch is remembering, that 192.168.1.2 lies at this particular MAC address, and the other IP lies at that MAC address. So what we try to do in ARP sniffing is mess up with that table. We just tell the router something like this. So let me put it diagrammatically because I don't have a whiteboard. So I'll just try to rephrase what I just said because I'm not sure how many of you got it. The first interaction is a common interaction when there is no attack happening, right? LAN user, the hub and switch is taking care of sending the traffic between the user and the routers, right? But here in this case, in the case of ARP cache poisoning, a malicious user comes into picture and it enters in between. It is a man in the middle attack. It enters in between the LAN and the router. So whatever, whether you're visiting any website or whether you are adding, like joining this meeting, you're doing it by telling your router that I want to reach here, right? And your router takes care of directing that traffic to you. What are we doing in ARP poisoning? We are entering in between. So we tell the router that Aditi's machine MAC is not this. So this malicious user here, what is this person trying to do? This person is telling the router, which is your LAN gateway, that the MAC address that you have saved for this IP, right? The IP of the user is not Aditi's MAC address, but that is my MAC address. So basically it's trying to impersonate my identity. It's just saying that I am Aditi, send all the packets to me. Okay, so it can tell router that. And how does it do it? It does that using ARP protocol. So ARP is a protocol which is address resolution protocol. The basic function that ARP does is resolving the address, that this is the IP of this MAC address and this is the IP of that MAC address. Now we just create and send fake ARP packets. So we send fake ARP packets telling the router that Aditi's MAC is not the original MAC, it is my MAC. So I am Aditi. So this is the communication that we send to the router as malicious user. And then, but Aditi will still communicate to the router, right? So we have to create another packet to Aditi and we send that, hey, the router address that you have, right? That is wrong. I am the router, right? So it's like just playing a very evilish role. It tries to impersonate the identities. For router, I become Aditi's MacBook, and for Aditi, I become the router, right? So whenever there's a traffic from MacBook to router, it goes through me. And whenever there's a traffic from router to the MacBook, it goes to me again, right? So that is how I'm able to put myself in between and see all the packets which are going back and forth. So that is what is called MITM, which is man in the middle attack. And this is the technique in which we are doing it. There's another technique which is MAC flooding. In that case, we basically craft a lot of packets and make the switch act like hub, right? So the table that it has, right, it has a fixed size. Now MAC flooding basically floods that table. So switch just leaves all the information. Switch basically has no, remembrance or memory of which IP belongs to. So basically they have messed up with the switch, right? You send so much packets to the switch that switch is clueless now that which IP belongs to which MAC address. That is what happens in MAC flooding. That is something that we won't be doing right now, but we'll definitely be doing ARP poisoning, which is this one, where I'm just placing in between these two entities and I'm not messing up with the switch. I'm just messing up with the identity of the target, right? So that is what is happening. So just revising, address resolution protocol is the one which resolves IP address to MAC addresses. It is broadcast based, so a router sends it to everyone, to all the devices connected on that network, that who is having this particular IP. And that is why me being a hacker, I can say yes to an IP that doesn't even belong to me, right? And then that changes the table. There are a lot of tools in which you can use for doing ARP spoofing. So this attack that we're talking about is called ARP spoofing. It's also called ARP poisoning. And there are a lot of tools to do that, but I would recommend that you create it on your own, right? Like just use a very basic Python package, which is called SCAPY. You can use the package and create this attack on your own. And I can also share the Python code with you if you want to do that. So we'll be using SCAPY here, which is a network packet manipulation tool. And the code looks like this. So let's talk code a bit, okay? Because that will help you in understanding it more. So opening up an idle. Yeah, so this is what the code looks like. Take a minute and just try to read it, what's happening. Python is very basic, so even if you do not know it, you can make sense of a little bit of it. It's trying to get MAC, it's trying to spoof ARP cache, and it's trying to restore ARP towards the end of it. And what is very important in all of it is just these two lines, okay? So this is SCAPY library, which is a Python library which I downloaded and included in this particular project. This has this method defined that is spoof ARP cache, and you tell the target IP and the target MAC and the gateway IP, right? So basically coming in between the information, we'll be sending a packet to the router saying that I am the MacBook Pro, the target, and I'll be sending a packet to the target saying I am the router, right? So it's just doing those two things using these two commands. And in the end, it just quits. It restores the cache so that the person can communicate at ease now that you have hacked the person already, and you just get done with it. So we can try this script right now. I think we have some time. I really wanted to do Q&As, so let's see if we can get at least 5 minutes for Q&As. So what should we do? We should try to... So I have this sample mobile, it's not mine, so I have this test device, and what I'll try to do is that whatever this device is sending, I want to capture it through my MacBook Pro, okay? Okay, so let's see how the device looks like. This is this. I'm just using an app Visor which can show my device's screen to you folks, because we'll be getting one information from the device. Okay, come on. So meanwhile, you can go to your own device and see what is the IP of your own device, okay? Try to figure out. It should be somewhere in the settings, in the Wi-Fi settings, you can see it. Because that's what I'm gonna do here. I'll just be picking up my IP from that device and nothing else. So while it does this, you'd also need WIRESHARK. Okay, so this is a device, and I'll just go to settings and I'll go to Wi-Fi, and then here, right? And then in somewhere here I see this IP address. You see this? It's 192.168.1.14. Okay, that is the IP. And what's the IP of my Mac? That we already know, it's 1.2, right? We can see it again if you want. So it's 192.168.1.2, this one, okay? So these are the two IPs, and my router's IP is this. So this is the gateway, 192.168.1.254, right? So now I have to come in between these two by running this script. So let's just run this script. Let me clear this. We have, this is not present on desktop, so let me go to the top. It uses Python 3. You would not be able to do it on Python's other versions. So what happens when I run this? It asks for an enter target IP. So my target is right now this mobile, right? So I just enter 192.168.1.14, okay? And then it asks me to enter the gateway IP, and it's not asking me my own IP because this script is running on my system, so it can easily get it. Okay, 192.168.1.254, right? So that is the gateway IP, and now I'll enter it, and it'll start ARP-ing. But before that, I want to capture the traffic, because I want to make sure that you are not seeing any traffic from 14 right now. Okay. See, there's just no traffic from my device because I cannot see it because Switch is taking care of it. Switch is not sending me the packets intended for that device. But now I'm going to perform a MITM attack, and I'll be able to get the traffics which are intended to targeted to this device. So let's just run that script here. Now it's doing sending spoofed packets, sending spoofed ARP responses, and what do we see here? We see that somehow we are able to capture these traffic. This is going from my system, right? This is like mobile, and I'm able to see the traffic from my mobile. Now let's visit some sample website. Let's visit, say, example.net, because it is kind of HTTP website. So we'll also try to mess up with the HTML that we get. So I'm just visiting example.net, which is one website. And is it loading? Is it a real website? Let's try some other browser. And another important thing is that this should work. Okay, because if it is not working, it might mean that you're doing something wrong because you're intercepting the packet. So you need to handle it properly. If you're not able to handle it, it might happen that maybe there is some mapping wrong, but it's not in this case because it should basically be working. So let's just try to capture it. You also see that a lot of DNS packets are there. I just want to visit an HTTP site so that I can filter it from HTTP and we can see the packet on MacBook Pro and be happy about it. Example .NET. Okay, let's go. This is the place where I'm trying this thing out. I think it's like a typical demo thing. It's not working because it's something different. Let me see if I'm able to see any traffic here. We can just pick up that example. I was talking to Google, which is kind of very basic because it's an Android device. So there will be like a lot of Google account traffic going around, Google APIs, because it uses a bunch of them. And then there are some other traffics which are going around. Okay, there's some other thing which is going on here, but never mind. I think the browsers are not loading, maybe because I was messing up with them last night. I did some proxy settings, but this thing is kind of working right here. Like we're able to, I just visited Bing, so we can see some Bing queries here. Okay, and there is like Android client thing. So we are able to capture the traffic from our Android device, which is pretty crazy because all it needed was just this ARP spoofing attack. So it is still running. And when I cancel it, it's basically, wow, you just cancel it like this, and then it'll stop, it'll reset the ARP, and you'll be good to go. So you will no more be the man in the middle. So that is what I wanted to show. We are 5:59, and I'd be very happy to take any questions if there are any. Let me know. I'll just wrap this up. Hello?
Yes, Aditi.
Yes, Saiti. So that is all I wanted to cover majorly. I think we are about time.
Oh.
So are there any questions?
Yeah. So we'll wait for the attendees to ask.
Sure.
I think